So today we are learning how to sketch quadratic graphs, so quadratic graphs, and we want to learn, the different kind of transformation that it can undergo. So when I said the word transformation, I mean, the quadratic graph will, undergo or look differently. So it could stretch, okay, to make it wider. It could, squeeze. It could go narrower, right? It could reflect and so on. So let's just start off with the first example here. So we want to investigate the graph of y equals to ax. And to do that, I'm going to bring up Desmos. Okay, so y equal ax, so a is the coefficient of x squared. Sorry, I meant to say y equals ax squared. So there's a 1 there, right? So there's a 1x squared. So I don't put a 1 there. So this is the graph that you guys should be quite familiar with from the previous lesson. Alright, so this is the graph of y equals to x squared. Okay, so what if I make a less than 1? Okay, so if a is less than 1, so let's say a is 1/5 or 0.2, what will that look like? So I'm just going to sketch that, plot that. So you can see that the blue line here is a lot more narrower, a lot more wider, I should say, than the red line. Okay, so the blue graph is a lot more wider than the red graph. So let me just create another one. So if I go y equals to, let's say, 0.5 x squared, and you guys can see that this graph here, I'm going to change the color of that one. So let's just change it to green. So the green graph here, okay, is again wider than our original graph, which is y equals x squared. So what we can conclude from this is that when a is less than 1 or greater than 0, so between 0 and 1, okay, not inclusive of 1 or 0, the graph goes wider, right? So let's put that aside. Let me just put that aside now. I'm done with that. So that's that. So what happens when a is greater than 1? For example, a is 2. So our number here is 2. So what happens then? So when a is 2, we can see that the graph is a lot more narrower. It gets squeezed in, right? Gets squashed in. So that's that. Now I'm going to hide this one. Now I'm going to plot this one here. Actually, plot that one. Okay, so I'm changing the value of a. So a is 0.1, and we're looking at the purple dotted line. And I'm going to increase that slowly. Well, that's a bit hard. So now a is equal to 1. Okay, so a equals 2, a equals to 4.75, and so on. So we can see from this investigation, if a is greater than 0, then our graph becomes more narrower or more squished, right? More narrow. So let's come back to our notes over here. So I'm going to write down here. So if a is greater than 0, greater than 1, okay, when a is greater than 1, okay, our graph, not our graph, the graph becomes more narrow. Okay, and when it's between 0 and 1, our graph, or the graph, becomes more wider. Okay, so it's been stretched out. So now these two transformations that we've just done, is called dilation. Okay, dilation. Okay, so that's when we are stretching or squashing the graph. That's called dilation. Now let's look what happens when a is less than 0, when it is negative. So let me bring that up. So let's do this example here. Actually, we'll start off with just negative x squared. Let's start off with just negative x squared. So let's plot that. So as you can see, okay, when I plot y equals negative x squared, we get an upside down, well, just a reflection of y equals x squared, right? So it becomes upside down, okay? So now if I go y equals to negative 3x squared, let me do that over here. So y equals to negative 3x squared. You can see that it's negative, and you can see that it has been squashed, okay, because we have a 3 in front of it, okay, so we're squashing it. And if I just copy and paste that in the next line and change 3 to 0.5, and you can see that it makes it a bit wider, okay, so between 0 and 1 it makes the graph wider, okay, and anything greater than 1 will make the graph more narrower. Okay, so hopefully that makes sense. So let's come over here, and we will say that when a is less than 0, the graph will reflect about the x-axis. Okay, so this here is called reflection. So this is called reflection. Okay, this transformation is called reflection, when the graph reflects itself. And the top one is called dilation, when we stretch it or squeeze it. Okay, so stretching and squeezing is called dilation. And let's move to the next part. Okay, so let's look at the graph. Okay, x squared plus k, where k is just a constant or a real number. So k could be 3, it could be negative 5, it could be 2.7 or something like that. Okay, so let us have a look. Alright, so let me get out of here and go to that one there. Let's open up that graph. Alright, so here's our base graph, y equals x squared. Okay, so let's see, what does y equal to x squared plus 1 look like? So what does this plus 1 at the end look like? Okay, so k is equal to 1. So doing that, we'll, okay, so this here, can you see, it shifts the graph up 1 unit, or it moves the graph 1 up. Okay, so 1 unit up in the y direction. Okay, so if I plot the next one, it will move the graph up 2 units in the y direction and 3 units up in the y directions. Okay, so let's hide that. So what happens if k is negative? So negative 2. Okay, so that will bring the graph down 2 units in the y direction. So the red graph just gone down 2 units. Okay, it looks like it's a different graph. It looks like it's been, you know, stretched out, but in fact it's not. So let me just show you. Okay, so all these graphs here are the same graph. So if I were to plot this graph here, so this is y equals to x squared plus k. So if I change k to, let's say, 0, you can see that the graph has moved up to the red line. And if I, you know, bring it down to negative 2, okay, so it has moved 2 units down in the y direction. Okay, so hopefully that makes sense. So basically the k at the end, or the value at the end, the constant term, that just shift the graph in the y direction, or shift the graph in the, shift the graph up, or shift the graph down in the y directions. So let us make a note here. So we say k, okay, when k is positive, okay, the graph will move up, okay, k units in the y direction, okay, and when k is negative, okay, the graph will move down kg units in the y direction. Okay, so when the graph is moving up or moving down, okay, we call that translation. So we call this kind of transformation translation. Okay, this just means moving left, right, or up, down. Okay, so in our particular example, it's gone up and down. Hopefully that makes sense. So I'm just gonna pause there for a second to see if anyone's got any questions in the chat. Okay, look like there's no questions, so let's continue. Alright, so now we are going to look at this kind of graph here. So what does this kind of graph here look like? Alright, so now we're not going to do this one, the last one down here, so we'll do that next time. Otherwise, we'll go on forever. So let's, where is my, here it is. So come out of here, so we're looking at this kind of graph now, so let's open that. So here's our base graph. Okay, so what happens when h is 1 over here? So we got -1 over here. So what is the graph going to do over here? So let me, maybe I might make that a little bit bigger for you guys, so hopefully you guys see a bit better. So here we got y equals to x minus 1 in bracket or square. What is going to happen? So let's just find out by plotting it. And as you guys can see, it has moved 1 unit, 1 unit in the x direction. So it's gone towards the right, okay? So let's do another one. So we have x minus 2 in bracket, square. Okay, so as you can see here, is moved 2 units towards the right. And if I go +4, hopefully you guys can have some kind of idea where that goes. I'm just going to plot it. And it has moved 4 units to the left. Okay, so it's gone 4 units to the left. Okay, and let me just generalize that. So here I have, okay, so h equals to 0. So that's the black dotted line is on the red line right now. So I'm going to move that, okay, towards -1, as you can see. And now I'm going to move it towards -2. And I'm going to move it towards -4. I'm sorry, +4. Okay, so h equals to 4. So, okay, so hopefully that makes sense what's going on. When the value is positive, it goes towards the left. And when the value is negative, when I say the value, I'm saying the value inside our bracket here. When that's negative, okay, it gets moved towards the right. And when it is positive here, okay, +4, it gets moved 4 units towards the left. Okay, so that's what it's doing right there. Okay, so I should stop using the word move. Okay, the word that we're meant to be using is called translation. Okay, so it's translating towards the left or towards the right. Okay, so let us, so we can say here, when h, okay, so see how there's a negative there. So when h is positive, okay, it translates the graph towards the right. Okay, and some of you guys might be confused of what's going on here. I'll explain in a minute. So when h is negative, it translates the graph towards the left. Okay, so I'll just explain what that means. So when h is positive, we'll just get y equals to x minus h squared. And when it's minus h, we know that it goes towards the right. Now when h is negative, so when h is negative, so when we got y equals to x minus h, okay, square, then we'll get y equals to x plus h all square. And when it's in this form, okay, the graph moves towards the left. So let's just look at that again on Desmos. So here, okay, so here we have h as being 1, okay, h is 1. So when you have x minus 1, it gets translated towards the left, towards the right, okay. Again, here it's going to translate towards the right. Now here, when we have x plus 4, okay, then it gets translates towards the left. Hope that makes sense, guys. If it doesn't, have a play with it, and if you're still confused after that, then let me know. We'll try to we'll try to work through it. And that's it for today's lesson.